Hello friends, as John F. Kennedy rightly said, let us think of education as the means of developing our greatest abilities because in each of us there is a private hope and dream which fulfilled can be translated into benefit for everyone and greater strength of the nation. So, my dear friends, myself Tushar Patel, Assistant Professor of Department of Civil Engineering from the College Mahatma Gandhi Institute of Technical Education and Research Center, Navsari, would like to say that today's topic name is Natural Phenomena. Today, I'll try to cover with the general content of the natural phenomena and the four types of phenomena that are wind, waves, tides and currents. So let's move to the introduction. In an harbor, there are many activities of water, but they are all affected by natural phenomena. These then to have an impact to the harbor by different kinds of motion of water caused by these phenomena. The four major natural phenomena are winds, waves, tides and currents. Now, what is wind? Wind is a horizontal movement of air due to the difference in the air pressure which are caused by the differential heating and cooling. In short, wind means air in motion. The path of the wind is modified by the rotation of the earth and its topography. So my dear friends, there are three kinds of wind characteristics that are important to all of us. Direction, frequency and intensity. The direction of the wind is usually specified by the compass. The frequency of the wind is the percentage of the time in a year it will blow from a particular direction, and the intensity gives the velocity of the wind. Hence, in maritime words, we can say that speed of the wind is expressed in knots. 1 knot equals to 1.85 km per hour. Now let us move to the definition of the waves. The water waves are generated by the transfer of energy from air moving over the water surface. These are the periodic undulations of the sea surface. See the figure. Here we are able to see the wavelength of each of the wave that is transmitted towards the seashore. There are many causes of sea waves. Some of them are listed such as wind, the revolution of the earth, gravitational forces of the moon and the sun, earthquakes in the water surface, and the landslides on the seashore. These are some of the causes of the sea waves. Now, let us talk about the types of the sea waves. Some of the types are listed below. First one is the deep sea wave. The second is the shallow sea wave. The third is the oscillatory wave. Now, what do you mean by oscillatory? These are unbroken waves traveling in the deep water and remain in the oscillatory motion. Translatory waves. When the oscillatory waves reach shallow water, they break and travel as a translatory wave to the shore. Next up, we have the capillary waves or the ripples. There are three types of capillary waves. First is the surfs. The low height and the long waves produced by the wind are called surfs. In Western countries, tourists play skiing by long plank on these waves. Second is the surges. The waves produced by the cyclone are very strong and powerful and are known as surges. These are produced by the cyclone's effect. And last one is the tsunami. The waves produced by the eruption of volcano or an earthquake at the bed of the sea is called tsunami. So my dear friends, here are the list of the different type of sea waves. In this figure, we have shown you the deep sea wave, the oscillatory wave, the capillary waves. In the capillary waves, there are number of names. In this, the three most important names we have specified: the surfs, the surges and the tsunami. And last one is the shallow sea wave. Next, we move across to the characteristics of the waves. Now, as you are seeing in this diagram, you have been shown in the green the wavelength, in the orange the amplitude, in the red we have the wave height, the green number that is trough and crest. So what are these known as, or what is their definition? So first of all, let us move to the define of crest. The highest point of the wave is known as crest. So it means that the highest point of any wave, in this figure it is shown, the highest point in any of the waves is known as crest. So naturally, what is trough? Trough is the lowest most point of the wave. Now let us talk about wavelength. The distance between two successive crests or two successive troughs are known as a wavelength, denoted by capital L. Wave height, the vertical distance from the crest level to the trough level is known as a wave height. And wave period, the time taken for a wave to travel a distance of one wavelength is called as wave period, denoted by capital T. So my dear friends, if we talk about frequency, so the simplest definition is the reciprocal of the wave period is known as frequency. F equals to 1 by T. The velocity of wave will be denoted by L by T. What is L? L is the wavelength and T is the wave period. So the angular frequency of the wave equals to 2 pi by T, that is 2 pi divided by the wave period will get you the angular frequency. Now let us move to the determination of wave velocity, fetch, wave height and wavelength. If we talk about wave velocity, the wave velocity is denoted by V equals to L by T, where L represents length and T represents wave period. Now what is fetch? Fetch, the straight line stretch of open water available for the wave growth without the interruption of land is known as fetch. Stephenson has developed an approximate relationship between the wave height h and fetch f. It is expressed by the equation h equals to 0.34 under root f, where h equals to wave height in meters and f, that is fetch, equal in kilometers. Next we denote the wavelength. The length of a wave, which is the distance between the consecutive crests of a wave, can be expressed by Bertin's formula. What is a Bertin's formula? Bertin's formula is L equals to T square divided by 2 pi into G, where the L, that is length of the wave in meters, equals to 1.56 T square, and T, it is denoted by the wave period in seconds. In this figure, you have been shown the crest, the trough, the height of a wavelength and the wavelength and the distance or the time taken. Now let us move across to the wave breaking. Waves break when the forward velocity of the crest particle exceeds the velocity of the wave propagation itself in deep water. Wave height, when it exceeds 1/7 of the wavelength, the wave normally breaks. Ocean waves on breaking against a marine structure gives rise to the following effects. Now what are these effects? First, the compression due to direct horizontal force. They form the shearing action at the projections of the face of the wall due to deflected vertical force. Third, suction effect due to the return water after striking. Now it is normally in a case when you stand at the ocean beach and when the wave hits you, right, you tend to have a shear action and the projection on your feet. But once the water goes back, that is the suction effect that creates, right? So that effect is known as the suction effect. Lastly, the seabed and the foundation disturbance due to the downward force of the collapse of the wave. Normally, by these effects, some may result into inertia force, vibrations, internal pressure, and expansion and contraction of cavities of the structure. Now, the internal pressure on the air in the pores and the cavity of the structure is equal to 3.5 times of the pressure of water on the face of the wall. In case of masonry structure, these forces have a severe damage effect. But whereas if it is a mount type of structure having numerous voids, the internal pressure gets relieved itself. So my dear friends, it is trying to say that if your wall is of a masonry structure, then it is forcibly trying to say that it will get a severe damage to itself. But if your type of structure is mount type, which has many voids, or I may say many holes in its structure, the internal pressure gets relieved. So by this, the wave breaking will have a lesser effect to the breakwaters. Next is the wave reflection. Non-breaking waves acting on a vertical wall such as a breakwater, cliff or steep beach do not lose their energy by impact but are reflected. So the principle of wave reflection is showing in this figure. The wave incident on a vertical barrier, are reflected. Due to this continuous interaction of the incident and the reflected waves, a wave of higher height is formed, which is called the standing wave, also known as clapotis. The standing wave may reach a height which is twice the height of the incident wave. So, the methods that are to minimize the wave reflection inside the harbor are: breakwater must be aligned in such a way that the reflected waves from them are not directed towards the pier and other harbor structures, or that may try to damage those structures by force. Secondly, interior slopes of breakwaters can be designed for a wave to break, which spend the wave energy. It is more likely to say that the energy should be broken off, or else it is the waves that will damage the structure and the waves that will damage the ships that are on the seashores. Lastly, special spending beaches can be planned at a points of maximum wave action in an harbor. Next, we move across to the third natural phenomena, and that is the tides. Now, due to the gravitational force of the sun and moon, there is a rise and fall in the oceans. These are known as tides. The rise of the water level are known as high tides, and the fall in the ocean water level is known as low tides. Generally, there are two high tides and two low tides every lunar day. That is, two successive high tides or low tides is about 12 hours 25 minutes. Every day, the tide comes 50 minutes later than the tide of the previous day. In example, in the Mediterranean Sea, the height of the tide is nearly 0.5 to 1 meter. But if in the Gulf of Fundy, the height of the tide is 15 to 20 meters. So let us talk about the types of tides, the classification. So as you are shown in this slide, there are many types known as spring tides, neap tides, semi-diurnal tides, diurnal tides, mixed tides, and tidal bores. So let us talk one by one of each effect. Now, spring tide, also known as the moon tide. These are highest tides which occur at the intervals of half a lunar month. They occur when generating forces of the moon and the sun are additives, means the summation of the forces of moon and sun. This happens when the sun and the moon and earth fall in one line. Next, Neap Tide. This is the lowest tide of the month. It occurs when the lines connecting the earth with the sun and the moon form right angle. Means the earth, sun and moon form a right angle to each other. This happens when the moon is in its quarters. In this case, the action of the moon and the sun are subtractive. Means the moon and the sun forces are subtractive to each other. The next is the semi-diurnal tides. These are the tides which occur twice each lunar day. Moon crosses the observer's meridian twice in every 24 hours and hence generate 2 tides a day. Now everyone will ask me, what is lunar day? So lunar day means the time taken by a moon to complete one complete revolution around the earth. Next is the diurnal tides. These are the high tides which occur only one time a day. Example, Florida. Next is the mixed tide. If one of the two daily high tides does not reach the height of the previous tide, it is called as the mixed diurnal tide. It normally happens in San Francisco, California and USA. Lastly, tidal war. These are high crested waves caused by the rush of flood tide up a river. They have a regular occurrence at certain locations as in the Bay of Fundy. Now let me explain you in this figure. See the spring tide, moon, the full moon, solar tide and lunar tide. Whereas the Neap tide has a formation of the perpendicular distance between the sun, earth and the moon. If you have to see the tidal bore, these are the tidal bores. These are high crested waves caused by the rush of flood tides. See in this figure, you may be able to see the flush tides. Next one is the semi-diurnal. These are the two high tides and the low tides at each and every specific time interval. Diurnal tides, these are the high tides occur once in a day. And these are the semi-diurnal mixed tides. Right? If one of the two daily high tides does not reach the height of the previous tide, they are known as mixed semi-diurnal tides. Now we come across to the uses of tides. First, tides can be used for harnessing the power. Now the Central Water and the Power Research Station is studying the possibilities of harnessing the tidal power at the Gulf of Kutch, the Gulf of Cambay, Sundarbans, etc. Tides are used for the entry and exit of the ships in the harbors. Now it is a normal effect that if a ships want to enter or exit the harbor, the tides have to give their way to them. Fishermen takes an advantage of the tides. As we all know, tides because of the tides, the energy that is used in the ships or the diesel, petrol that are used in the ships are less in number. So that is why fishermen takes very much advantages of these tides. Due to the tides, the seashore and the ports remain clean. Now, due to the continuous effects of the tide, the particles that are present over the water surface or the bed of the water, due to these tides, they wash out each and every time they pass by. Lastly, high tide water can be used for harvesting salt. Last topic of today's lecture will be currents. Now what are currents? The word is similar and very much to our consent. Currents are essentially a horizontal movement of water. See in this figure, you may be able to see the horizontal movement of water. Now water cannot be a very smooth run. We do not have any water surface that is following a smooth run. So currents are these horizontal movements of water. Now what are the causes of currents? It may be tides, wind blowing over the ocean surface, the difference in the temperature and salinity of the seawater, the turbidity of water, lastly wave breaking at an angle to the beach. Normally it tends to see that when you reach the seashore, the wave, when they reach the seashore, the waves normally try to break each other and those form the currents. Now, what are the effects of currents? It may be a cause of scouring and erosion to the seabed. Many a times, the silt deposition takes place. The currents are having a high turbidity of water, which in case increases in corrosion rate. It may be that a modification of wave effects are caused due to the effects of current. Impact of ice on marine structures may be then ultimate effect of an current. Currents delay in the construction operations. Significant forces on maritime structures. Lastly, the loads on the moor vessels. Because of the current, the vessels or the ships have a horizontal movement to each other. It may be that it is desirable that to a large extent harbors are free from both erosion and silting. Erosion may undermine the foundation of the structures and silting will result in the reducing the depth of water in the approach channel and the turning basin, which also impacts the ships. Now the classification of currents. Currents may be classified according to 5. Primary ocean currents, turbidity currents, tidal and wind drift currents, wind stress currents and littoral currents. Now what are primary ocean currents? These are produced by the density difference caused by the difference in the temperature and salinity of the sea water. The steeper the density gradient, the faster the current. The major ocean currents are all primary interest to the oceanographers and meteorologists as they represent a massive transport of water and exert a major influence on the world climates. Second is turbidity currents. These are caused by the mixing of bottom sediments with the seawater, resulting in an increased density of water locally. For example, currents produced by underwater landslide. Turbidity currents are the importance in the silting of deep water structures and in case of submarine pipelines and cables. So, due to the mixing of bottom sediment into the sea, resulting in its density increase, we say those currents as turbidity currents. Next is the wind and the tidal drift currents. Now, great importance to a structural engineer in planning and design of the fixed and floating structures. These tidal currents are a horizontal flow of water associated with the vertical rise and fall of the tides. Next is the wind stress current. Now, wind blowing over the ocean surface tends to drag the surface layer of the water along with it through frictional shearing stresses. Winds blowing with higher velocities for a longer period may produce significant surface currents. These are known as wind stress currents. Lastly, littoral currents. Littoral currents are set up by the waves breaking at an angle to the beach. As the sea wave approaches the shallow water, they become the waves of translation and pile up water against the coast. A hydraulic grade line is thus established and must be a return flow to the sea. The component of the wave along the coast give rise to the current which carries the sediment along with it. This is also known as littoral drift. Now moving across to the littoral drift, as you see in this video, the aerial view of the coastal beach, in it a sand particle. Now see literally how the sand particle is being dragged by the incoming wave in the direction of the ocean current. See the sand particle being dragged or pushed to the shore. Now as the water goes back, the suction effect, the backwash, the particle goes in a similar direction. These zigzag line in the proximity of the coast is known as longshore drift. So the longshore sediment movement takes place in the narrow zone along the coast where the wave breaks. In this zone, the wave creates the longshore current transporting the sediment, which is then brought into the suspension by the breaking waves. Beyond the breaker zone, the longshore sediment movement decreases rapidly in a seaward direction of the drifting sand in a zigzag line in the proximity of the coast. This is known as littoral drift. So thank you for your patience. This is the end of this spectacular topic. Thank you very much.